Uh, Welcome friend to this session of design patterns. This is an introductory section of design patterns, and what we'll do is we will try to understand the definition of design patterns, and also we will try to walk through those three main important design patterns, uh, three main categories of design patterns, and get a feel of what exactly is design patterns. First thing, let's just scroll through the definition of design patterns. They are documented and tried solutions for recurring problems. So you have a problem and then you have a solution. These solutions and problems, are basically nothing but they have been documented from whatever experience we have got from the IT industry. So you can say that it is like a documented best practices for software architecture. But remember one thing, that design pattern is not a silver bullet. Many times I get questions from IT people, saying that how can we implement design patterns in our project. My answer is to it is sometimes, uh, first thing, your project well. Every project is different, you know issues are different with the project, then the way of approach is different in the because domains are different. So it's something which well. What you can do is that basically you can take up the design pattern as a reference. Okay, look at whatever design patterns we have, 30-40 design patterns we have, take it as a reference. Look into your project problem and see that does it really solve your project problem in a very simplified manner. If it solves, then implement that pattern. So do not overdo design patterns. Always remember that patterns are for projects and projects are not for patterns. I've seen so many times, developers, trying to force design patterns in the projects, and it completely messes up the software architecture. Design patterns have been existing from long time back. If you remember in your college times, if you're told that you need to implement a sorting algorithm, then the first answer that will come to your head is bubble sort. So the problem is sorting, or the context is sorting, and the solution is bubble sort. Now again, it's very much possible, that the data of sorting can be very different. So even though people say that use bubble sort for sorting, you will try to use your own sorting algorithm. Why? Because you know the problem well, and if you think that bubble sort doesn't fit, please try to implement your custom algorithm which can simplify the project. So it is nothing but you have a problem context and the proposed solution. We can divide design patterns into three main categories. One is, or we can say, we can divide design patterns into uh, three problem areas. The software architecture into three problem areas. Okay, I mean to say every software architecture or software uh, design will have these three problem areas. The first problem area is the creational issue. Okay, and all these creational issues can be solved by creational patterns. So basically, let's say that you have a huge project, lot of classes. Okay, and when we have a lot of classes means you have a lot of objects. Okay, and when we say a lot of objects, you definitely need to create them. Okay, when we say create them, for example, if you have a CLS invoice object, you need to definitely say new CLS invoice somewhere, right? So if these objects are, if the object creation are scattered at the scattered on the client code, it leads to a lot of complicated logic in the client code. For example, you have a CLS invoice, a CLS accounts, classes, and these are classes names which I'm specifying. So you will say like create a new object of accounts, create a new objects of order, create a new objects of quantity. And if these object creational objects are, if this the creation of the objects is not centralized, it will lead to a very complicated code. Creational patterns helps us to centralize these object creational process in one class, and and thus minimizing the complicated logic at the client code. Second issue, or we can say the second software architecture issue, is the structural issue. Sometimes you would like to change the structure of classes, or we can say the relationship between classes, but you don't want the project to be affected. For example, if you have classes like CLS customer and CLS phones, and the CLS phones class is used inside CLS customer, so there is a relationship of one as to many. But tomorrow, as the project proceeds, you say the customer says, can you please keep the customer away from the phones because I want to use these classes independently. Now what it means is that the customer object and the phones object now are both now need to be operated independently. So here's a structural change, and with this change you don't want this structural change to actually affect over the project. Okay, you want to do it seamlessly, and that is where the structural patterns comes into. Structural patterns helps us. The third is the behavioral issues of software architecture. Sometimes you want to change a behavior of a class, but you don't want that again to affect the other projects in the other classes in the project. For example, let's say that you have a CLS invoice. Okay, and the CLS invoice basically takes applies taxes. Okay, so whenever you print an invoice, there is some 30% tax which has been applied on the invoice. Now what you want is, tomorrow you want to change this behavior a bit with the additional taxes what it is now implementing 30%. You would also like to implement some more additional taxes, which are nothing to do with the normal taxes. Okay, now what you are trying to do is that you want to change the behavior of the CLS invoice, how it is operating, or the invoice object, how it is operating. These type of behavioral things can be solved by behavioral patterns. I hope I was able to walk. Every software architecture issues lies into three main categories. One is a creational, second is a structural, and third is a behavioral. And for all these three categories, we have these three patterns. When we look at software architecture, one of the main issues with the software architecture, any kind of big project, is how do we control the object creation? How do we centralize the object creation? Let's say that you have thousands of classes in your project, and then your client code starts creating objects. Probably let's say that you have an invoice object, accounts object, order object, and your client code is creating them, using them, closing them, destroying the objects. Now what happens with this is that your client codes become very complicated. The first thing. Second thing, your client code is very much heavily tied up with the main concrete objects. So this leads to heavy coupling between the client code and the main concrete objects. So in order to solve this problem, we have creational patterns. So in creational patterns, basically you centralize, or you can say you delegate the object creation to a different class, and this class is used by the client to get objects. Second issue with with software architecture is the structural changes. To manage structural changes, for instance, let's say that you have a CLS customer class, and you have a phones class. So basically one customer can have multiple phones, so the phones class is aggregated inside the customer class. Now this is the structure of your project, and it is working well for past 1 or 2 years. Now suddenly the customer comes with a request saying that the phones is a different entity and the customer is a different entity. They should be independent for whatever reason. Now here you want to make a structural change, but you also want to see that it doesn't affect throughout the project. So that is where structural patterns comes into place. Third is a behavioral pattern. Sometimes you would like to change the behavior of a class, and you don't want that this change of behavior should affect the project anywhere. For example, that you have let's say that you have a CLS order class. Okay, order class, and this order class, when you place an order, you are checking for the validity period of the product. Okay, and the validity period is 30 days. Tomorrow you need to change the behavior of the class, and you say that it is not 30 days anymore, it is probably 2 months. So you are trying to change the behavior of the class, but with the change of behavior you also want to ensure that it doesn't affect the project a lot. It just changes the exact place where we need to change, or the exact entity which needs to be changed. So basically all the software issues, or software architecture issues, or software design issues, they lie into these three categories, and all these three categories are addressed in design patterns by approximately 40 design patterns. We have approximately 40 design patterns, and all these design patterns lie into one of these categories. So in the sense, these three categories form the main part of the 40 design patterns. In the coming tutorial, we'll be walking through all the 40 design patterns. So please first get comfortable with whatever we have introduced please first get comfortable with all these three main categories, because when you start looking into those subcategories of design patterns, or the actual design patterns, you should be able to map why, to which category do they belong to. Any questions, any doubts, please don't shy away from shooting me. Any kind of silly questions, please don't shy away from emailing me. And second, if you think that this tutorial was not good, please mail me your feedbacks. We'll try to improve on the same.